Hello everybody and welcome to another edition of Timwe Presents. Today we have an obligatory nonogram puzzle for you, made by EpicToast for the KTANE Puzzle Plethora. Now obviously obligatory is a bit of a joke, but anyway, we have a puzzle here that consists of 3, 4, 5 separate nonograms, each with special rules, and then we have something at the bottom that we haven't figured out yet. I haven't looked at the puzzle at all yet. And I'm just going to use Paint and dive straight in. I'm just going to take a screenshot of this and put that in Paint. And then I'm just going to start. Okay, so this, as a standard nonogram, I assume standard nonogram rules, which means that 1, 1, and then 4. Aha, that doesn't quite fill the whole thing, but at least it fills those 3. Alright, now I'm also going to fill everything with a sort of medium gray. So we're done. Now let's see, where else can I go? So there is a 5 here. So let me take that color here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, that needs to be black. Now I notice that this row has only 1s, so this is going to be white, and this is going to be white. And I think I'm going to use a 0 tolerance on this filler tool. Okay, so what else? Nope, that doesn't really... Okay, let's see what I can fit here. 1, 2, 3, 1, 2. Yeah, that can go down 3 more spaces, so I can't really do... look at this, 3 and 4. Okay, there's still 1 degree of freedom, but it means that these 3 and these 2 must be filled. And then from the 3 clue here, we immediately know that must be filled. And then from the row that has only 1s, as in only singletons, we know that those 2 must be set. This one must be set because this column must start with a 1 group, and by set I mean empty. Right, similarly here these start with 1 groups, so these must be set off with white. And now there is only 1 way to fit in this column, so that finishes that off, which now means that that must be white, because if it were black, we would have to fill all of this, and then it would be a group of 6, and we can't have that. Alright, what else? 3 and a 1. Okay, so this must be white, because if it were black, it would create a group of 4. And unfortunately, the singleton could still be either here or here. Oh, look at that. The bottom row has only a single 1, so that must be entirely white. And that leaves only 2 ways to place the 3, which is either the top 3 or the next ones after that. Okay, now in this row, there is only singleton, so that must be it, which fills the rest of this column with white, because the 2 group can only be either here or here. What else? Okay, so we need a group of 3 here, so we can't fit that in here. And this one must be black, because no matter where you put the 3 group, the middle cell here will always be black. And that means that cell must be part of the 3 group here, which means that is black and this cannot be black. Okay, 3 and 2, 1 and 3. Let's see. In this column, this must be filled. There is no other place to put the second singleton. Not so much in this column, you could still fit 2 singletons here, but that means that this must be white, because, again, it would have to be blacks after that, and that would create a 6 group, which we can't have. So this is where the 3 goes, and that satisfies the entire top row. And that's that. We can't fit all 3 of these singletons in here. There's just not enough space for the singletons and the gaps between them, so that must be filled, and that finishes the 3 group. What else can we do? Aha, so this here is a 2 group and a 1 group. This cell must be part of the 2 group, and this must be part of the 1 group, which means that we can set this to white, and this must also be white. There's just no other place to put the 2 than those 2 and those 2 cells. Now looking at the first column, that one must be white. This must be the 3 group because the row started with that. That must be white because the row is now finished. And that finishes this 3 group and also the rest of the column. Now these 2 must be part of the 3 group, can't be part of any of the singletons because it's already 2 together, so that must be white. And that satisfies that entire column. And also this column here, right? We need 3 singletons in this column. That finishes the 3, and in fact now there's only one place to put everything. Same in the first column. Here we have a 3 and a 2. There's only one way to place that. Okay, so the 2 is done. This row needs a singleton, and that finishes this column. That finishes the 5. That finishes the 2. Okay, so this is our first result. A plus sign, a rectangle with a cutout corner, something that looks perhaps like an upright arrow and an up arrow. I don't know what this means yet, but I'm quickly going to save this file. Okay, and now we're gonna move on to the next nonogram and see what that one has in store. Now this one says, normal nonogram rules apply, but the numbers 1 to 5 are replaced with letters A to E, though not necessarily in that order. Okay, so each of these letters refers to a different number from 1 to 5. That is very interesting. In particular, that means we don't have any groups that are bigger than 5. Okay, so now I'm going to try and just select this and use the brightness tool to turn it into some kind of gray. There we go. Okay, that should work. Okay, so one of these must be a 5. You know what? I'm going to increase the canvas size here a little so that I have some space on the right to put what I think the numbers may be. Okay, so let's create a new layer. I just want the background to be white rather than this checkerboard pattern. Okay, let's combine those two and get rid of that window. Okay, and here I'm just going to put A, B, C, D, E. Right, and initially each of them can be any number from 1 to 5, and I'm just going to use the eraser to remove them one by one. Okay, so let's begin. So one of them has to be a 5. Okay, so it should be quite easy to rule out some of them from being a 5. Right, let's do this. Okay, so if B was a 5, then we would have to have, 1, 2, 3, 4, 5 here, and then we would have to have 2 singletons, but A and D have to be different numbers. They can't both be 1s. Therefore, Bravo can't be a 5. So I'm going to remove that 5 here. Now, by the same reasoning, A and D also can't be 5, because they would make, if A was 5, then B and D would both have to be 1s. And similarly, if D was a 5. Okay. I think I'm going to use a slightly bigger brush here to erase these digits. Alright, let's do that. Okay, the same applies to any letter that appears in a column with 2 other letters. Unfortunately, the only echo that appears in the columns appears with just 1 Bravo rather than 2 other letters, and there are no Charlies in the columns at all, and the Charlies in the row all have only 1. Okay, so it's not quite easy. Oh, wait a second. Bingo, there we go, that last clue. If echo was a 5, right, then we would need to have 1, 2, 3, 4, 5 cells there, and then there would only be space for 2 singletons. which is impossible, and therefore echo is also not a 5. Okay, so that means that Charlie is indeed the 5. So we're just going to put that here. And this one I'm going to make bigger just to show that this is what it is. Okay, so now that we know that Charlie is indeed a 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Right, from both sides we meet in the middle, so the middle one must be filled no matter where you put the 5. Right, here, similarly, this must be 1, 2, 3, 4, 5, and then at least 1. So 1, 2, 3, 4, 5 goes at least that far. Same here, right? We have something that is at least 1, and then a 5. So that is what we have. Okay, now let's see. Can Bravo be anything 2 or greater, anything greater than 1? Well, we can fill 3 2's in here, but then there's no more space for the delta. So from that column alone, we can actually tell that it has to be a 1, even if we hadn't had this this cell here beforehand. 1, 1, 1, 3, or 2, 2, 2. Yeah, so if we put 2, 2, 2 in there, there's just not enough space for the delta. So we know that Bravo must be 1. So let's put that here. And let's also fill something because, well, 1, 1, 1, right? This has to be one of the singleton groups. So this has to be set off, and that fills in the Charlie here, which we know to be 5. Okay, so this is one of the Bravos, and the other 2 Bravos are going to be up here, which means that the delta must be a 2. So at this point, I think we can confidently say that delta must in fact be the 2. Okay. So, now obviously we now know that the other 2, alpha and echo, cannot be 1 and 2 anymore, because we know that they're all different numbers. So A and E are 3 and 4 in some order. Let's see if we can figure out which is which. Now we know that delta is 2, and we know that Bravo is 1. So 4 would fit and 3 would also fit. And here similarly, right, we could have either 3 like this for the echo, or we could have all 4, and there would still be plenty of space for both of the Bravos. So this doesn't really allow us to but wait, we know that the Bravos must use at least these cells. So this is the latest that the echo can finish. And since echo is at least 3, this cell here must be black. Even if we don't know where the Bravos are, this one has to be black. Okay, and we know that alpha is at least 3, right? So this here couldn't be white, because then you could only fit a 2 group in here, and then alpha would have to be 2. Therefore this is filled, and alpha is either alpha is either 3 or 4. We still don't know which one. But we know that delta is 2, and that actually fills that entire row now. Okay, so 2 plus 1. Look at this. We can actually fill in the delta and the Bravo here without knowing the alpha, right? Even though we don't know whether this is black or white, we know that the 2 group and the singleton, there's only one space for them. Right, this row here has only a single group, and that group has to have size 5, so these must be white, excuse me. Since alpha is at least 3, right, even if we put this as far up as possible, the delta does not fit above the white square, so it must be below it, and therefore these are both black. And now since this starts with an echo, we now know that echo must be 4. And this one here starts with a delta and then a Bravo, so all of those are filled in. So now we know that Bravo is 4 and alpha is 3. So we're going to put a 3 here and a 4 here. There we go. Okay, so now the rest is standard nonogram, I guess. Let's see. We need at least one. Oh yeah, that doesn't help. Okay, so this is a 2, 1, 2. 2, 1. Ah, okay. So if we were to make this a 2 group, we couldn't fit a 2 and a 1 up here because there needs to be a gap between them. Therefore, this has to be the Bravo, the 1 group, and then there is a 2 group here and a 2 group here. Now this row ends with a 1 group, and this row ends with an echo, which is a 4 group. This column ends with a 1, this column ends with a 2. So that's quite... in fact, this column has only 1s, so this must be set off, and this must be the Bravo, and then there must be a delta on top. This here has a 1 there, and then a 2 there, and that satisfies the rest of that column. And then there must be a 3 on top. There we go. We know that this row... okay, so we don't know if this one is the first singleton or the second one, but either way, it must be a singleton. This column here ends with echo, so that must be white. This is where the Bravo is for this row, and that puts the alpha here. Okay. Now alpha is 3, 3, so that must be white. We must have 3 1s here, we still don't know where that is. We have 2, 1, 2, we don't know where that is. Okay. Okay, this row has only a single 2 group, so it can't be anywhere here because we already have a black pixel here. And that might disambiguate some of these. This column is now complete. This column here can only be done one way. And that finishes the top row. Right? You see, if this was the first singleton and this was the second one, there would not be enough space to put 2 2 groups there. Therefore, this has to be a 2 group. This has to be the last 2 group. Oh, I see. As soon as I knew that Bravo and Delta were 1 and 2, I could have already fit all of that in there. Okay, so here we need 2 3 groups, so that's white, and that is a Bravo, which is a 1. And then Delta is, of course, a 2, so that must be set and that must be unset. Okay, let's quickly save that as the second puzzle. All right. And now we move on to the third one. This is a question mark nonogram. Normal nonogram rules apply, but some numbers are replaced with question marks. The question marks can represent any number greater than 0. So effectively, it only tells us what groups there are in each row, but not how big each group is. So that means we need to rely quite heavily on the clues in the columns. Now let's do this again like I did last time. Like that. There we go. Okay. Now this row here needs to have 5 separate groups. 1, 2, 3, 4, 5. Right, there's only one way to fit that. They must all be singleton groups. This must be a singleton group, this must be a 3 group, this must be a 4 group, this must be a 3 group, and this must be a singleton. Okay. This row can only have a single group, so they must all be connected, but we don't know how long the group is. This one here has only 2 groups in the entire column, and there is no space here for a 2 group. This has only 1 groups, singleton groups that is. There is no space here for a 2 group, so that must be empty. And here there are 2 places to put each of the 2 groups, but they all overlap by 1 pixel. All right. What else? Let's see, 3, 1, 1. That gives us 2 pixels here. Oh, do you see what I'm seeing? Let me just make sure that this logic is actually correct. Yeah, that's right, because we need another 1 pixel here. So now that we know that there is a pixel here on the far left and a pixel on the far right, and there is only a single group in that entire row, it must all be black. All right, so that must be a 1 group, that must be a 1 group, that must be a 1 group, that must be a 3 group. That is a 2 group, this is a 4 group, and another 4 group. Again, this row has only 1 group, and we know where that is. Let's see, we have a 4 group and a 2 group. There is not enough space for a 2 group down here. And in fact, there is only one way to fit a 4 and a 2 in here. Nice. Okay, this column is entirely satisfied. We already have both of the 2 groups. We already have both of the 1 groups in this column. And now there's only one way to fit 3 groups in the bottom row. They must all be singletons. This has only one way to fill the column. 2, 2, 1. Okay, there's only one way to fit the 2. This row can have only 3 groups. And this can't be a separate group from this one. So this can be at most 1 group. So the middle group must be in this pixel. And that fills that rest of that column. The 2 groups in this row, well, we don't know how long they are, so we can't say anything about those. Now this is getting interesting, because let's see. 3, 1, 1, 4. The 3 here is done. And that separates out those 2, which means that there can't be a 3rd group over here on the right. We still don't know how big the first group is, but we certainly know that these are white pixels now. And now there is not enough room here for the 2 groups, so that must be white. And that must be the second 2 group. Now we already have 2 groups in this row, so this must form a single group. And in this row, we can still turn, this column here dictates that must be a 2. So therefore this is a single group, so each of these must be separate groups to fulfill that row, and now that fulfills that. And I think we're done, because we have our 4 pixels in this column. So that looks like that is the solution to the 3rd puzzle. Alright, on to number 4. We now have a double nonogram in which some cells are red, and red cells function the same as normal black cells, but they count as 2 squares. So presumably that means that when we have a 6 and a 9 here, let's transfer this first, and let's make everything gray. There we go. And now I'm going to have to use separate colors. Now, since this is a 9 by 9 grid, then that means that obviously you can't fit 12 pixels in there, but they need not all be red, right? Because, so what I could do is I could fill these with red, and that would form a 6 group, and then I could fill these with red, and that would form a 6 group. But there are ways to move this around. In fact, even this would be a valid 6 group, wouldn't it? 2, 4, and then 6. So it's really not clear, and also the blacks don't even have to be on the outside, right? You could have this be red and this be black, and that would form a valid 6 group if I understand this correctly. So let's think about this. Right, okay, so 6 plus 9 is 15, plus the gap in between them is 16, which is very close to 18. And I strongly suspect that this is the closest we're gonna get. So let me see if I can, okay, so this would be a valid 6 group, and then in order to get a 9 group, I need something like this, right? One of these pixels must be black. Yeah. So I think literally the only way to fit the gap between the two is in this position. So I think this has to be white, and the ones on top have to be red. But the ones below don't necessarily, I don't know which one is red and which one is black. So the way I'm going to mark that is by giving them an even darker gray, like that. Yeah. Oh, look at this. Now that I know that this cell is not white, it means that the leftmost group in the bottom row must include that cell. So the separator between the two 6s must be either here or here, but I still don't know which. And also, I still don't know whether this would be black, this bottom cell. I don't know if this would be black, because even if this is red, you could totally fit a 6 group here by making that one white. So that is still quite uncertain. Now, singletons must be black, right? There is no way that you can have one group with a red cell, because the red cell would automatically count as 2. Which also means that these 3 groups here, there must be a black cell on either side of this red. But I don't know which side. Look at this. This is clever. If I put a black cell here, obviously I would have to set this off with white. And then I would also have to set this off, as in make this white, because there's just not enough room for 3. The most I can make it is red, which is 2. And now I cannot fit another 2 groups of 3 on the right. No matter where I put the white, I will end up with a single square. So that's how I can tell that this one must be the black, and these must be the whites. And that means that there must be another group of 3 on the left, which consists of a red and a black, but I don't know which one is which. And here on the far right, I know that the middle one can't be white, but it could be either white or black. Red or black. Okay, now that we know that this column starts with a black cell, we require at least 2 more cells to make a 4 group. But it could be 4, right? It could be 4 blacks. Okay. Oh, wow, this is really this is difficult, because all of the standard sort of nonogram tactics don't work on this. This is really cool. So in this row, let's see, what is the most condensed arrangement that I can make on the far right? I could put the 3 like this, and then the 2 like this. So either way, no matter how I arrange the 3 and the 2 ones have to be on the left of that white cell. Right, as soon as you put one of the 1 groups here, by which I mean here, as black, there's just not enough space there. Okay, so both of those blacks have to be here, and that has to be white. Okay. Now, this cell cannot be part of the 2 group, because this column starts with the 2 group. The 2 group could be 2 blacks or a red, but this black has to be part of the 7 group, which means that it needs at least 3 more cells. And yeah, the third one could be here. So this is so we know at least that. Now, in order to get a 6 group at the start of this row, we need at least 3 cells, and now we know that it will be 4 cells. This row could start with a black, if it wanted to. This is fascinating. So, let's see how we can fit in these groups of 4, because you see, I could make this red and this black. Right, but I need at least 2 cells to accommodate the other 4 cell group. So it can't go on the top, it has to go on the bottom, and there are only 3 cells of space there. So that one has to be non-white. Okay. I strongly suspect that this puzzle is going to take me quite a while. Let's see what is the most compact that I can put these. For a moment there I thought I broke the puzzle, but no, of course I could make this one red, and then that would be the most compact representation. Oh, look at that. Look at this. This actually requires that arrangement. There is just no other way to put that. Okay, so with that being red, we now know that this 3 group needs another black on either side. But we don't know which side yet. But this is really good. I need to pay attention to these. Right, okay, so for a 3 clue we need at least 2 cells. For a 2 clue we need at least 1. For a 1 clue we need 1. And for a 3 clue we need 2. So this cell is also completely forced. But not completely, because we don't know which ones of these are red. But wait, this one cannot be red, because that would make that a 4 group. Therefore, this is black, this is white, and in order to make the 3 group in the column, that has to be red. And that finishes the 4 group in this row. This is really cool. Really cool. Okay. Let's see. Unfortunately, okay, I can make this white, but unfortunately I don't know whether that 2 group is a single red or 2 blacks. Can it be a red? I don't think... look at this. It can't be a red here, because that would violate the 4, because now this is at least 5. But it could still be a red here. And it could also be a pair of blacks. And that wouldn't make all of these black, which is still possible at this point. So I don't know. Let's see. Look at this. This 6th row cannot reach all the way up to here, right? The furthest it can go is 6 blacks, and the least it can go is 3 reds, but we already have 4, so it doesn't matter. Let's see. This 4 requires at least 1 more cell. Oops, I meant to put that, because there are 2 here. This one could be red. Oh, but could it? Oh, look at this. Now that we have so many whites in here, the only way to fit a 2 group here is a red. The 1 group must be black, which therefore requires this of the 4 group. And then for the 3 group, right, so first of all that needs to be set off to be a 1 group, and then for the 3 group we need another 2 grays. Okay. Now, this 7 group needs to go at least this far. So that's already 2, 3, 4, at least 4. And it could have all of the 7s. Right, it's at least 4, which means that with another 3, yeah, these could all be black, or they could all be white. So I don't know that yet. All right, let's see what else I can deduce. 3, 2, 1. This is forced. Look at this. The only way to fit the 3 is using 2 cells. The 2 must be a red and the 1 must be a black, and there's just too much white on the right to allow anything else. So that places a white here and a gray underneath, which means that the second 4 group must consist of 2 reds here, and the other 4 group could, yeah, it could still use all 4 of these. Okay. Oh wow, this is amazing. Let's see, 2, 2, 4. These could be reds. These could be reds or blacks, but they can't both be black. Oh, wait a second. This is a 9. 2, 4, 6, 8, 9. So this can actually accommodate only 1 black. As soon as we have a black in here, the rest has to be red. Otherwise, it would be smaller than 9. All right, let's take a look at this column. Oh, no, let's take a look at this column, because think about whether this can be white. Yeah, actually it can. I can just make all of the others red, and that would totally satisfy that. So we don't know if that is white. Can this have anything in it? No. Right. This square cannot have anything in it because, well, first of all, if we did have something in here, then this would have to be white. Otherwise, this would be a group of at least 3, which is not allowed in that column. So that would have to be a white. And similarly, this one here, right, or rather this one, you can't make this one black because that would be at least 3. So that would have to be white. And now we have 4 separate groups. So therefore, this must be white. And because this entire row has only one group, that must also be white. And that means that the 2 group is at the top, and the 7 group is down here at the bottom. Now let's see, we already have 1, 2, 3, 4. Yeah, so it could go all the way down, or it could actually all be red. That would work. How far can the 5 go? We already have 3 here. 4, 5, so that must be white. Right, because if that was something, then this would already be at least 4 plus 2, 6. And that's too much. So that has to be white, which means that has to be red in order to satisfy the 2 in the column, and then in order to satisfy the 3 in the row, that must be black. And that also forces the 2 in this column. And now to... Right, okay, so now we know that this must be at least gray. We have 3 already. And we can only accommodate 2 more, so the rest must in fact be black. Right? If any of those were red, then that would already make 2, 4, 6. Okay, so that is white. Very cool. Very cool puzzle. All right, 2, 4, 6. Yeah, so we could make this a 7. So this column here. Look at this, look at this. This has to be a row of 4 blacks. Because as soon as I put a red here, because this one here has to be at least 1, that would be at least 5. And obviously if I put a white here, then that would mean there is a singleton group, and we don't have that. So that has to be black. And then that has to be black, because if it were red, it would be too big. And that finishes that entire column. Okay. Oh, I'm definitely getting somewhere, and I'm loving this. This is brilliant. In this row here, we now have 2 whites sandwiching that cell, which needs to be a 2 group, so that needs to be red. We still don't have the black that we need in this column to make that, and to force the other reds. So I suspect that it's not going to let me do that. Okay, so let's see. 2, 2, 2. Look at this. This can't be gray now, because if it was, that would already be at least 3. So that actually has to be red, that has to be white, and this has to be white, because otherwise that last group would be too big. Which means that the... so that has to be white, and now there is only one way to fit 2 6s in, which is this. So now, in order to do the 4 in this column, I could have a red here. But I could also have a white here, and it could put a red here, and that would still work. Let's see, how many do we have here? 2, 4, 5, 6, 7. We already have 7 in this row. These must be black. And then in order to finish this 4 group, that must be black. And the 2 on the bottom is already satisfied, so that must be white. And now, we can't say anything about the 5 group yet. This here must complete to a 2 group, And then that must complete to a 4 group, which means that is red. Okay, and now since all of these have to be at least 1, they would already add up to 5, so they must all be black. Okay. Now let's quickly check that this satisfies all of the columns, because, yeah, see, the columns would have also forced that. Now, in this column, yeah, okay, so this is at least 1, and this is at least 2, right, or let's put it this way, this is at most 2, and this is at most 2, which is at most 4, so we need at least 1 more here, right? We don't know whether that's black or red, but look at this column. Aha, that actually tells us that these must be black, because they're at least 1. Okay, and that finishes the 3 on the left of this row. And now 2, 3, 4, 5. Yeah, that is still a little... but this row here, that requires a 2. Now we have 4, 5, 6. Still don't know where that goes. What about the 6? 2, 3, 4, 5. So we need exactly 1 black and 1 red in this row. Okay. I'm trying hard not to do trial and error here, but I strongly suspect that if this is red, because this needs to be 6. Oh, wait a second. Right, no, okay, so because that needs to be 6, that means that would have to be white. And then in order to finish the 9, that would have to be red. And then that would actually work. Okay, so I expect the opposite to give me a contradiction. So let's quickly try that out. So this would give me that. Bingo. No, wait a second. 1, 2, 3, 4, 5. That would be black. And then you have 2, 4, 5. Bingo, that doesn't make a 7. Okay. Yes, okay. So we've got our solution. We know that must be red, then that must be black, and that finishes the 9, and the 5 is done. Okay, so let's save that as obligatory nonogram puzzle 4. All right, that was amazing. I love that. That rule set is very creative. I'm very impressed. And now we have an off by 1 nonogram where every clue is wrong. So let's open this up. And now I'm going to do 2 things. First, I'm going to do the gray coloring as we've already discussed, but I think I'm also going to try and make these numbers. See, I want to make them all sort of stand out so that I know that they are still wrong, as in off by 1. You know what I'm saying? So I think what I'm going to do is I'm going to select all of this. I'm going to invert the colors, not the selection, there we go. And then I'm going to use curves, which is Control-Shift-M, to take out some red. That doesn't seem to affect anything. And now if I invert it again, yeah, I expected that to be a bit more red. Let's see if I can do that again. In fact, why don't I put this on a separate layer and then have the curves affect this layer. Okay. I see, the effect was just too subtle. There we go, this should work. So let's do that and then invert the colors. Bingo, so now they're red. Which means that now I know that they're all wrong, and I can use a black text object to paint over them. Alright, so for example, for the zeros, I already know that those need to be 1s. Because obviously, if you're off by 1, and it can't be a negative number, then it has to be a 0. So let's put a 1 where all of the zeros are. There we go. Now I suspect that the 1s, whoops, I meant to put a single 1 there and a single 1 there. There we go. Now, am I currently on a separate layer? Yes, I am. So let's just quickly merge those two layers. Now, it says here that 0 cannot exist in a multi-number clue. And surely that implies that all of the 1s must actually be 2s, right? So I can already put those in. So that must be a 2, that must be a 2, that must be a 2, and all of these must be 2s. Ah, come on. Let's just do it like that. There you go. This one here must be a 2, and this one must be a 2. Okay. Now, let's see what we can do with that. Okay, so can this be 2 space 2 space 2? Okay, so there is some latitude there, but we already know that this must be black, this must be black, and this must be black. And since this must be at least a 2 group, that must also be black. But it could still be a 4 group. In fact, let me see if it could be a 4 group, right? If this is a 4 group and this is a 2 group, yeah, you can fit a 1 group in between and that would work. So it could actually be a 4 group right now. So what about this one? This must be at least 3. And this one here could be a 1 group, so we don't know. Ah, but this can't be more than 5. So the rest here must be white, which might significantly curtail the possibilities in the other groups, right? So if this is, look at this, right? The 4 can only go down to 3. And even if we put 3 up here, there's not enough space even for a 1 group above it. And therefore, at least those 2 must be on. Oh! And it must, in fact, be a 3 group, because there is not enough space for a 5 group. So that is a 3. Very good. Okay, so for a moment there I thought, well, these numbers here add up to quite a lot, but then I realized that each number can individually be either 1 more or 1 less, so there is no reason to think that all of the 2s would have to be all 1s or all 3s. You could have a single 1 on the left and then a 3 and then another 1. Actually you can't. Oh, look at that, look at this, look at this. Right, even if 2 of the 2s are just 1s, if you want 1 of the 2s to be a 3, then there's simply not enough space for the one that is given as a 3, because it can only go down to 2, and there's just not enough space for that. Therefore, right, we don't know if that starts on the left, but we know that the 2s are all singletons. Right, and even as singletons, there is still not enough room for a 4 group. Right, so this must actually be 1, 2, 1, 1. There's just no other way to fit that. Okay, and I think we can also tell, well, first of all, that's a 1 group, but I think we can tell that this must be on, because if it weren't, right, because it has to start with a 1 group, that would have to be the 1 group, and then there's just not enough space for the rest there. Therefore, this has to be on, this has to be off, this has to be the 2 group, and then the 1 group is in one of those 2 pixels. All right. This vertical group could be a 2 or a 4. But with that white pixel here, there is now no more room for a 3 group in the bottom part. So that is actually a 1. It's funny, I know that it's a 1, but I can't tell where it goes. At least not yet, but we'll figure that out. So this 4 here needs to contain at least 3 pixels. Right, and those 3 pixels have to be in the top part. So those have to be set. And there's not enough room for a 5 group, so it is in fact a 3 group. And then there is only enough space down here for a 1 group and another 1 group. Okay, so that is actually a 3, 1, 1. There we go. So the logic that we used here to determine that none of the 2s can be a 3, maybe that applies here as well. Right? If any one of those 2s was a 3, and the others were the smallest they could be, then the 3 clue would have to translate to a singleton, which it can't. So all of the 2s here have to be singletons, and even then, the 3 clue can't translate to a 4. So that is necessarily 2, 1, 1, 1. That doesn't fit. Alright, fine. I'll put them in separately and squeeze them together. Let's do that. There we go. That's a 2, 1, 1, 1. Okay, now if I squeeze that in, 2, 1, 1, 1. Okay, there is 1 degree of latitude, but that has to be on, no matter where things are placed. And if this is on, then... never mind. Look, can this even be a 4 group? Yes, it can, because you can have a 2 and a 1. But alternatively, you could have a 2 and a 3, and then a 2 group. So those both work. But those are the only possibilities, right? So the leftmost 2, it definitely can't start here. It could start here, I suppose, but then there's not enough space. Oh yes, there is. There is space for a 1 and a 2. Oh my gosh, so many possibilities. Okay, so I can't tell anything about that. Can this 4 be a 5? 1, 2, 3, 4, 5. Yes, there's still enough space for 2 1s. Let's see, 3, 2, 2. See, if this was a normal nonogram, then 3, 2, 2 would just fit perfectly. But it isn't a normal nonogram, so it's either 2, 1, 1 with a lot of leeway, or maybe it's 4, 1, 1 with a little leeway. Anyway, I'm getting sidetracked. Let's take another look at where else we can go. This can still be a 5 or a 3. This can be a 1, 2, 1. But it can't be a 1, 2, 3. Look at this, right? You can't have a 1 here and then the 2 group there. That just doesn't work. Therefore, this has to be the 1 group no matter what. And then you can't fit a 2 and a 3 in here. So that must be a 2 and a 1, which means that one has to be black. Yeah, I think that's right. Okay. Look at this. The bottom of this column must be at least 2. And that there is only barely enough space for that. And there is no space for a 3 group anywhere. We don't know where the 1 group goes, but it is a 1 group. Okay, now this row here must start with either a 1 or a 3, and then the rest must be a 3 or a 5, which means this is definitely filled. Because even if it's just 1 and then 3, the 3 would have to go somewhere here, and the middle one would always be filled. Alright, so this column mandates, so it needs to end with a 2. And now this row is done. This column has almost only singletons, so that must be off. And now, right, no matter whether this is a 3 or a 5 now, yeah. See, even if this is a 3, it could only go like here, for example, right? It can't go further left to make room for this to be a 1. Right? That can't be the 1. Therefore, the 2 has to be a 1, and they have to be here. Okay, that's really cool. So, look at this on the far right. We know that these are all 2 groups, so we can actually set these. And this row must end with something that is at least 3, so that must be set. And that satisfies the 1, which means that and it has to start with at least 3, so that has to be set. And now there is only enough space for 3 and then 1 and then 1. No, you could actually have 5 and then 1, so that still works, right? But that must necessarily be set, we know that. And now this row, look at this, this can no longer be a 4 group, right? These have to be, because there is only 1 group in the row, this has to be connected, and that already makes it 5 cells. So it needs to be a 6 group. That is amazing. Okay. Three, 1, 1, 4, 2, 1. Aha. Oh, nope, never mind. I was about to make a mistake. But look at this row here, the 1, 2, 1. There's only that much space for it, which satisfies this column, right? So now this has to be a 1 because we actually have a 1 group there. And then the 4, and then there's only one more group, so we have to connect them, and that makes it 4 pixels. So it can't be a 3 group anymore. That has to be a 5 group. And we know that this row ends with a 1 group. And we know that this column has a 2 group. And we know that this is a 6 group. Wow. Okay, so this can no longer be a 3 group now. There's just no space for it. So that's a 1. Look at this. The 4 has to be at least 3. Right? So even if we put that as far left as possible, the 2 cannot be a 3 group. So that must be a 1, and that must be a 3, right? And on top of that, there is only 1 degree of latitude. So we can fill that in for the column. And now we know that this must be white because this row has to start with a 2 group. If we make this black, it would start with a 3 group or more. So that would be white, that would be black. This must be the 2 group here. That finishes the 3 group. This dictates the 3 group here. And now let's go back to this. This ends. It could still go either way. Yeah. Okay. It's fascinating how long that holds out. Okay, so this column here already has 2 groups, so that must be, that must be white because the top one here needs, the top 2 rather, has to be a 1. Okay. This column here has to start with at least a 3 group, and therefore this pixel must be part of the 3 group. Yeah, there are still 2 possibilities there. Let's take a look at the rest. We know what this column is, 2, 1, 1, 1. This can't be black, because then in order to make a 2 group, that would have to be black, and that would make a 3 group. Therefore, that is white, and now the entire column has only one way to fit all of that in. And that means that this can't be a 3 group anymore. That is a 5. Very good. And up here, this could still be 3, 3. This could we finished the group on the right here, so that needs to be a 2, which means that the thing in the middle, because there are now 2 separate pixels, they have to connect into a 3 group. Okay. We now know that this is a 1 group, although it doesn't hurt to notate that, but it's also not necessary. But now, if this was a pixel, then that would have to be a 3 group, and then you can't satisfy the 3 anymore. It would have to be at least a 2 group. So that can't be black, and this has to be a 1 and a 2, because there's just not enough space for anything else. So that is actually a 2 followed by a 1. This row here has 4 pixels, so it can't be a 3 group anymore, so that has to be black. So that makes that a 5. This column can still go both ways. This row requires at least 3 pixels in here. It could be 5 pixels, but we now know where the 3 goes in this column. And now this can't be a 3 group anymore, so that is... I keep pressing the wrong mouse button. That has to be a 1 group. And now this entire column here is done, which means, now this can't be a 5 group anymore. So that is actually a 3 group. Still don't know where to put it. But I do, because this column is now done. So that's where the 3 goes. And that means the 2 here is a 3, which means the 4 has to be a 3, and we are done. Okay, I'm just quickly going to fill in the numbers. I don't think that I will need them, but just in case that I do, yeah, that should be it. So let's save this as obligatory nonogram puzzle number 5. Okay, so now comes the presumably difficult part. We have, thank God this is 9 by 9. 9. So I could, in theory, superimpose this on top of the nonogram grids and see what I get. Right, so let's start with the first one. Let's create a new layer here. Make the, just move this over like this, I guess, and make this layer semi-transparent, 128. Okay. ANS rule. For a moment there I thought semaphore, but there's an L. I really don't know what this is trying to tell me. Let's see. Rule BT in the SNS. What about the letters that are not black? Yeah, that doesn't seem to give me anything. The plus has an N in the middle. This arrow has a Y, and then an M, NYM. Something nym, like synonym. Yeah, I really don't know where to go from here. Okay, let's try this. Let's try this on the other puzzles. Let's try it on this one. Let's put that here, and this time, before I want to stretch this a bit so that it fits. Right, let's go. This is 128. Elman Cis. I think I might need a hint on this. I don't think this this is easy. I can't really read anything into this. I don't know what to do here. I mean, I can tell that some letters are sort of trapped, so to speak. Like, okay, so for example here, let me just mark this in red so I can show you what I mean. Right, this one here is trapped in between the black pixels. So you could say NANT, but that's not a word either. Yeah, also, like, we have 5 separate nonogram grids, and only 1 letter grid. How is that 1 letter grid supposed to work for all of them? Let's look at this one. Let's see if I can deduce something here. Yeah, I just don't see anything. It's possible that you guys are screaming at the screen and hoping for me to see the obvious. But I just don't see it. I'm seeing some random letters, and they're not forming words. Just for completeness, I'm just gonna continue with the remaining nonograms, but I strongly suspect that the experience is just gonna be the same. let's see. So, I'm thinking the whole time, what would I do if I was the author of these puzzles? How would I, what kind of extraction could I come up with in which a single 9 by 9 letter grid could be used to extract information from separate nonograms? And the only way to do that is that each nonogram can only extract a few letters so that they don't clash. Right, so this is the last nonogram. Let's put that there. There are quite a few trapped letters here, M, T, W, P, A, but those don't seem to form a word either, at least not when read in reading order. So we have lint. I'm looking at the black squares now. In the top row we have lint, and then we have man, and then we have almost the word cruel, but after that it breaks down. There's just no Ostellan words with an E. Yeah, that is not working. So I am going to ask the author for a hint, and wait a second, there are 5 letters here, and then 2, 4, 6, 8, 10, 5, and then 10. Okay, so that's 15. So if I extract 3 letters from each nonogram, I get 15 letters. I don't know how to get 3 letters from this. I suppose BOS, right? This is okay. Let's try that. We have BOS in a box. Let's see if each of them has like this one has SYS. This one has WAM. Does this one have? Yes, PLA. A group of 3 letters in a row, and this one has NDS. Bosses, WAM plans. Well, so the first 5 letters form the word bossy. Swamplands. Bossy swamplands. I didn't see that. I forgot to prepare the answer code, so I will be right back. And here we are back with the answer code in my clipboard. This is the answer code. Let's see. Bossy swamplands. And that is the right answer. Ooh! Ladies and gentlemen, we've solved Obligatory Nonogram Puzzle from the KTANE Puzzle Plethora. Wow, that was quite a journey. 5 separate nonograms, 4 of them with really amazing creative variations on the rules, and of course 1 introductory one, which, by the way, now that I think about it, the arrows point towards the box as a hint that this is where you're supposed to look at. And I'm guessing the plus up there is only there to make the nonogram unique. So that's totally fine. And from that point, the rest of the nonograms, yeah, you're just supposed to realize that they all have 3 letters in a row somewhere. And yeah, I love this puzzle. This is absolutely fair as an extraction method. And it is totally hinted by the arrows in the first one, and by the fact that you have 5 nonograms and 15 letters, right? So my theory then was it would be 3 letters per nonogram, and that was the answer. So thank you very much for watching. I love this puzzle very much, and I hope that you enjoyed this video as much as I enjoyed the puzzle. I will see you again next time when we have another puzzle from the KTANE Puzzle Plethora here at Timwe Presents.